Hello and welcome. In this tutorial, we are going to talk about the Newton's law of cooling. And as you are seeing on your screen, we have been given an equation, and as we know, that is a differential equation. And we have been told that T subscript S is the ambient temperature, T is time in minutes, K is a constant. So they have asked a question here: when an object is placed in a room with the temperature 12 degrees Celsius, it was found that the temperature drops from 75 degrees Celsius to 25 degrees Celsius in 30 minutes. Determine the temperature of the object after 20 minutes. Yes. So we are going to solve this question. Yeah. And we know that they have been given us dt, d lowercase t is equal to negative k into T minus the ambient temperature. And as we can see that this one can be can be solved using the separation of variables. We are going to separate the variables, and we are going to say we are seeing that this one can be taken to this side because dt is a change with respect to this temperature, which is in uppercase. So we are going to divide both sides by those factors. So we are going to have 1 over T minus the ambient temperature dt should be giving us negative k. Yeah, we have separated the variables. The next thing we are going to do, we are going to integrate both sides, and this one is going to give us the natural log of t minus ts, which will be equal to negative k t plus c. Yeah, from that point we can take everything using the exponents. So you can have the exponent here and the exponent there. We know that the natural log and the exponent are inverse functions, so they are going to cancel out. We are going to have ts is equal to, so you are going to have e negative k t, but you know the exponent raised power a constant is going to give us another constant. So we are going to have that constant, maybe let's us name it using another variable, let's say d, because we know from the laws of indices when we are adding the powers, it means that we are multiplying. So for instance, we are going to have e negative kt multiplied by e to the c, and we have said that e to the c is another constant d. So that is why we are having this value here. Yeah, and from the question that we have there, it is important to note that the ambient temperature in this case is 12 degrees Celsius. So you are going to have T minus 12 degrees Celsius is equal to D exponential negative K T. So from that point, we are able to note that it was found that the temperature drops from 75 degrees Celsius to 25 degrees Celsius in 30 minutes, meaning that at T is equals to 0, at T, at T is equals to 0, now the temperature is now 12 degrees Celsius. No, I'm sorry, not 12 degrees Celsius. At T is equals to 0, the temperature is 75 degrees Celsius. Now, if you're having 75 degrees Celsius at T is equals to 0, that means that if we substitute in the equation, we're having 75 degrees Celsius minus 12 degrees Celsius is equal to D exponential negative K into 0. I hope we are to get that up to that point. So 75, let me pick my calculator now because I don't want to make mistakes. 75 minus 12 is giving us 63 degrees Celsius is equal to, now anything negative k multiplied by 0 is 0 and e to the 0 is 1. So we have found our first unknown, that is D, is going to be 65 degrees Celsius. But we still need to find the value of k for us to be able to solve that equation fully. So we are going to say at t is equals to 30 now, because the change in temperature was in 30 minutes. At t is equals to 30 minutes, so we are having 25 degrees Celsius minus 12 degrees Celsius is going to give us D, because we already have D, is 63 degrees Celsius exponential negative K T, but T in this case is 30 minutes. So we are having 25 minus 12, that is going to give us 13. So 13 degrees Celsius is equal to 63 degrees Celsius exponential negative 30 K. So for us to find this value, we are going to have to divide both sides by 63 and take the ln. So realize that ln 13 degrees Celsius over 63 degrees Celsius is going to give us negative 30 K, because the ln of E will cancel. Ln E is 1, we know that. So for us to find the value of K, we are going to divide both sides by 30, so will be having 1 over 30 ln 13 degrees Celsius over 63 degrees Celsius is going to give us the negative of K. Yeah. So from that point, we are going to say, we are going to find the ln of that. So ln 13 over 63 is going to give us negative 1.578, and we are going to divide that by 30. We are going to get negative 0.0526 is equal to the negative of K. This implies that 0.0526 is equal to K. Hope up to that point we are together. So from that point, you are going to substitute everything back to the equation, this equation here. So you are going to have T minus 12 degrees Celsius is equal to D was 63 degrees Celsius, then exponential negative K, but K already we have it, so it is exponential negative 0.0526. This one is multiplied by T, and this one can also be moved to, can be simplified to 12 degrees. T is equals to 12 degrees Celsius. Now we are going to add 63 degrees Celsius exponential negative 0.0526 T. Yeah, and you're going to go back and answer that question that was there. Determine the temperature of an object after 20 minutes. So the temperature of an object after 20 minutes, so when T is 20 minutes, the temperature will be equal to 12 degrees Celsius plus 63 degrees Celsius exponential negative 0.0526. This one is multiplied by 20. Yeah. So if you use a calculator, you're going to get your answer there, and we're going to do that. So it will be 12 degrees Celsius, and we're going to add 63, and this one is multiplied by exponential. This one is multiplied by exponential negative 0.0526 multiplied by 20. Yeah, so you're going to use your calculator and find that answer. Stay tuned. Thank you for watching.